So let's start the exercise. First question is, the guru of a yogi lives in Himalayan caves, 1000 kilometers away from the house of the yogi. The yogi claims that whenever he thinks about his guru, the guru immediately knows about it. Calculate the minimum possible time interval between yogi thinking about the guru and the guru knowing about it. So this is the first question. So we know that the minimum or the maximum possible velocity is 3 into 10 to the power 8 meter per second. So time is distance over velocity. Distance is 10 to the power 6 meters because it is 1000 kilometers. And maximum velocity can only be 3 into 10 to the power 8 meters per second. So the minimum time can be 1 over 300 seconds. This is the minimum time that will be required. In question 2, a suitcase kept on shop's rack is measured 50 cross 25 cross 10 centimeter by shop's owner. A traveler takes the suitcase in train moving with velocity 0.6 c. If suitcase is placed with its length along the train's velocity, find the dimensions measured by the traveler and the ground observer. So question number 2. So the dimensions are this. And velocity is 0.6 c. Now first part. So for the observer in the train, if observer is in the train, so all the dimensions will remain same because relative to him there is no velocity of the luggage, so all the dimensions will remain same as it is. But when you are in a ground frame, okay, when you are in a ground frame, so in that case the luggage is also moving with 0.6 c, so the breadth and height will remain same because only the dimension along which the motion is happening will change. So if the motion is happening along the length, so only these dimensions will change. The height and the width will not change. So height will remain 10 centimeter, breadth will remain 25 centimeter. What about the length? So length will become L root 1 minus v square over c square. This is by length contraction. So 50 was the original length minus v square is 0.6 square into c square over c square. So from here new length will come out to be 50 into 0.8, which will be 40 centimeters. So the length will become 40 centimeter, that is it will reduce by 10 centimeters. So the dimensions will be 40 cross 25 cross 10 centimeters. In question 3, the length of rod is exactly 1 meter when measured at rest. What will be the length when it moves at a speed first 3 into 10 to the power 5 meter per second, second 3 into 10 to the power 6 meter per second, and third 3 into 10 to the power 7 meter per second. So the third question. So what do we have? We have length equal to 1 meter. So in the first situation, velocity is 3 into 10 to the power 5 meter per second. So length will be original length is 1 meter, so let's put 1 minus v square will be this much over c square, which is this much 3 into 10 to the power 8 square. So new length will be root 1 minus 10 to the power minus 6. So it will be around 0.9999995 meter approximately. In the second scenario, we have velocity equaling 3 into 10 to the power 6 meter per second. So in this case the length will be, again outside 1 will be there, 1 minus 9 into 10 to the power 12 over 9 into 10 to the power 16. So we will get root 1 minus 10 to the power minus 4. So new length will be around 0.99995 meters. In case 6, velocity becomes 3 into 10 to the power 7 meter per second. So L dash will be 1 into 1 minus 9 into 10 to the power 14 over 9 into 10 to the power 16. So which will give us root 1 minus 10 to the power minus 2. So new length will be 0.995 meters. So this is the length in 3 scenarios. In question 4, person standing on a platform finds that train moving with velocity 0.6 c takes 1 second to pass by him. We need to find the length of the train as seen by the person and the rest length of the train. So this is the fourth question. V is 0.6 centimeter per second, time is 1 second. First part, length observed by the observer will be velocity into time, that is 0.6 into 3 into 10 to the power 6. So it will be 1.8 into 10 to the power 8 meters. And for the rest length we can use this formula. This is given 1.8 into 10 to the power 8. L naught is the rest length that we need to find. 1 minus speed is 0.6. This is 0.6 c, sorry. So yeah, 0.6 c square over c square. So this will give us, let's simplify, L naught will be 1.8 into 10 to the power 8 over 0.8. So we will have 2.25 into 10 to the power 8 meters, original length. In question 5, aeroplane travels over rectangular field parallel to its length. What should be the speed of plane so that the field becomes square in the plane frame? So this means we need to change the dimension of 100 meter into 50 meters. So this is the fifth one. So we need to change the length to 50 centimeter. Original length was 100 centimeter. Okay, because the breadth will remain 50 centimeter. Oh, sorry, meters. It is in meters. So we need to find for how much velocity will this happen. So L dash equal to L root 1 minus v square over c square. So 50 equal to 100 root 1 minus v square over c square. So v will be root 3 by 2 c. So v will be 0.866 c. So for this much velocity, the length of 100 will become 50. In question 6, the rest distance between Patna and Delhi is 1000 kilometers. A non-stop train travels at 360 km per hour. What is the distance between Patna and Delhi in the train frame? How much time elapses in the train frame between Patna and Delhi? So this sixth question. So original length 1000 kilometers or 10 to the power 6 meters. Velocity is 360 km per hour or 360 into 5 by 18, 100 meters per second. Now A part, the new length will be 100 or 10 to the power 2, 3 into 10 to the power 8 whole square. So L dash will be 10 to the power 6, 10 to the power 4, 9 into 10 to the power 16. So it will give us 10 to the power 9. So the change 10 to the power 6, 9 into 10 to the power 16 minus 10 to the power 4 over 9 into 10 to the power 16. So it will be, let us remove this part here only. So it will become 12. So it will become 12 like this. So 10 to the power 6 over 3 into 10 to the power 6 and into 9 into 10 to the power 12 minus 1. So L dash will be 1 over 3, and let's solve this. So after further simplification you will find that the change in length, that is L minus L dash, will come out to be around 56 nanometers. Now the B part, time period, change in length over velocity, 56 nanometers over 100 meters per second, so 0.56 nanosecond. Question 7. A person travels by car at a speed of 180 km per hour. It takes exactly 10 hours by his wristwatch to go from station A to station B. What is the rest distance between the two stations, and how much time is taken in the road frame by the car to go from station A to station B? Seventh question. So velocity is 180 km per hour or 50 meters per second. Time is 10 hours or 10 into 3600 second. So L dash equal to L root 1 minus V square over C square. L dash will be 10 into 180, that is 180 kilometers. So 1800 kilometers. So 1800 equal to L root 1 minus 180 square or 180 square and 3 into 10 to the power 5 whole square, converted into kilometer per hour. So next is squaring both sides. So L will be around 1800 plus 25 into 10 to the power minus 12, or we can say 25 nanometer more than 1800 kilometers. B part, time taken in road frame by car. So it will be 1.8 into 10 to the power 6 plus 25 into 10 to the power minus 9 over 50. So it will be 0.36 into 10 to the power 5 plus 5 into 10 to the power minus 8. So 10 hours plus 0.5 nanoseconds. So this much time will be required. In question 8, a person travels on a spaceship moving at a speed of 5c by 13. We need to find time interval calculated by him between the consecutive birthday celebration of the friend on earth and find the time interval calculated by the friend on the earth between the consecutive birthday celebrations of the traveler. So this is the answer or solution 8. A part. U is 5c by 13. So the change in the time interval or time dilation will be given by this. So 1 year over root 1 minus 25 c square over c 169 c square. So we will obtain 13 over 12 years. And for this second part, the friend on earth also calculates same interval because it is reciprocal, or we should say it is whatever the one friend see, it will be seen by the other friend also. In question 9, according to station clocks, two babies are born at the same instant, one in Howrah, one in Delhi. Who is elder in the frame of 2301 up Rajdhani Express going from Howrah to Delhi, and who is elder in the frame of 2302 Rajdhani Express going from Delhi to Howrah? Ninth question. So birth timings by station clock are the proper time, that those are the proper time intervals because it is in the ground frame. And birth timings by trains will be improper time because it is not in ground frame. It records the time at two different places also. So del t dash will be v into del t. So for this train, Delhi baby is older because it started from there, and from the second train, Howrah baby is elder. In question 10, we have two babies born in moving train, one in compartment adjacent to the engine and other in compartment adjacent to the guard. According to the train frame, the babies are born in the same instant of time. Who is older according to the ground frame? So the 10th question. Clocks of moving frame are out of sync. The clocks on the moving trains are out of sync. Clock at rear end leads and clock at front lags. By how much? By L0 V over C square. Therefore, baby adjacent to guard cell is elder.